Welcome back to Cosmos Adventures, where we explore the mysteries of the vast universe together. Today, we're diving into a fascinating topic about Earth's neighboring planet, Mars. Mars is not only famous for its nickname, the Red Planet, but it also has two incredibly unique moons, Phobos and Deimos. Have you ever wondered, why does Mars have two moons? Where did these moons come from, and why are they so small and different compared to our own moon? In today's video, we'll uncover everything about Phobos and Deimos, from their origins and physical characteristics to their potential roles in future space exploration missions. Let's get started. Phobos and Deimos are the two small moons of Mars, discovered by American astronomer Asaph Hall in 1877. When observed through a telescope, we can see that both moons have unusual shapes, unlike Earth's moon, which is round. Instead, they have irregular, lumpy shapes, resembling giant space rocks floating in space. Phobos, the larger moon, has a diameter of about 22 kilometers, roughly the size of a large city. Deimos is smaller, with a diameter of only around 12 kilometers, comparable to the size of a large hill. Both moons have very close orbits to Mars, especially Phobos, which orbits closer to its planet than any other moon in the solar system orbits its host planet. But why is this the case? And why does Mars have such small moons? One of the main hypotheses that scientists have proposed to explain the existence of Phobos and Deimos is the capture hypothesis. According to this theory, Phobos and Deimos were not formed alongside Mars, but were originally asteroids. Imagine it like this. Between Mars and Jupiter lies a region full of asteroids, known as the asteroid belt. These asteroids come in all sizes, from just a few meters to hundreds of kilometers, orbiting the Sun along their own paths. In the distant past, due to gravitational influences from Jupiter or other astronomical events, some asteroids may have been nudged out of their orbits and wandered through space. As Phobos and Deimos approached Mars, the planet's gravity may have captured them, turning them into natural satellites of Mars. This theory explains why both moons are small and irregularly shaped, resembling asteroids that we are familiar with. However, the capture hypothesis faces a significant challenge. Both Phobos and Deimos have nearly circular orbits, whereas captured asteroids typically have highly eccentric, elliptical, and unstable orbits. This raises the question, could Phobos and Deimos have formed through a different process? Another hypothesis that scientists have proposed is the giant impact hypothesis. According to this theory, billions of years ago, a large asteroid or small planet collided violently with Mars. This impact would have sent a huge amount of debris into space around Mars. Under the influence of gravity, instead of escaping into space, these debris fragments began orbiting Mars. Over time, the pieces gradually coalesced, forming Phobos and Deimos. This scenario is somewhat similar to how Earth's moon is thought to have formed after Earth collided with a massive celestial body about 4.5 billion years ago. The giant impact hypothesis helps explain why Phobos and Deimos have nearly circular orbits, a feature difficult to account for if they were captured asteroids. However, one key issue remains. If the collision was so powerful, why are Phobos and Deimos so small? One would expect larger moons to form from such a significant event. More evidence is needed to definitively confirm this theory, and the origins of Phobos and Deimos remain an open question, fueling ongoing research and exploration of Mars and its moons. Although the origins of Phobos and Deimos are still debated, their structures and terrains have provided significant insights. Phobos, the larger moon, has a surface covered with craters, the most notable being the massive Stickney crater. This crater occupies nearly one-third of Phobos' surface. Scientists believe that a powerful impact created Stickney, and had the impact been slightly stronger, it might have shattered Phobos entirely. Deimos, the smaller moon, has a smoother surface compared to Phobos, though it also shows signs of impact. Due to its smaller size and weaker gravitational pull, debris from impacts is not pulled back to its surface, resulting in a relatively smoother appearance compared to the cratered and rugged Phobos. An intriguing fact is that Phobos is gradually moving closer to Mars at a rate of about 2 centimeters per year. This means that in roughly 50 million years, Phobos could be torn apart by Mars's tidal forces, potentially forming a debris ring around the red planet, much like Saturn's rings. This eventual transformation adds another layer of fascination to Mars's unique moons. Beyond being fascinating celestial bodies to study, Phobos and Deimos could play crucial roles in future human exploration missions to Mars. Because Phobos orbits so close to Mars, it could serve as a staging post for space missions. Spacecraft could land on Phobos and use it as a base to safely approach the Martian surface. This would reduce energy costs and increase flexibility for sending humans or robots to Mars. Additionally, scientists are exploring the possibility of mining resources from Phobos and Deimos. These moons may contain valuable materials, such as water or rare minerals, that could be utilized for space missions. Using local resources would reduce the need to transport supplies from Earth, which is critical for deep space exploration. These moons, therefore, hold great potential as stepping stones for long-term missions to Mars and beyond. So we've just explored the mysterious moons of Mars, Phobos and Deimos. While their origins remain debated, they hold secrets that may help us better understand Mars and the formation of our solar system. Phobos and Deimos aren't just small objects orbiting Mars. They could play a pivotal role in the future as humanity prepares to dive deeper into space exploration than ever before. What do you think about these two moons? Do you believe they are captured asteroids or the result of a massive collision? Leave a comment below and let us know your thoughts. Don't forget to hit like and subscribe so you won't miss any of our exciting science videos. Thanks for watching, and we'll see you in the next video.